Welcome back. So let's move on to the next part of the big data for engineers. I'll ask you the quicker question next week. It's a recap on HDFS. All right. So where are we? We know how to store data in S3, in Azure Blob Storage, in HDFS. Now we need to look into it at what data we store, right? So we are going one level higher. We saw that there are data shapes. I told you in the first week, tables, unstructured, cubes, graphs, trees. It turns out that when we use big data, of course, we love tables. Everybody loves tables, but we also love trees. And you'll see plenty of trees this and next week and the week after that. No, this week trees, next week tables, and then again trees, right? And you will get why I keep talking about trees. There's a reason for that. It's that a lot of data sets that you store in the data lake are actually like trees in terms of their contents. Right? So we are here. You see, I'm going bottom up right here, up the stack. We are done with storage with HDFS and S3. And now I'm going especially into the syntax, basically. The encoding barely, because that's not the focus, but we are going to look at syntax. It's what we are going to store in HDFS, starting with text files, in the sense of something you can open and read as a human being and understand. There's a lot of syntax. It can be just text, maybe the complete works of Sir Arthur Conan Doyle. That's an example of things you can store if you want to query unstructured data. If you love business stuff and want to store tables that you saved with Excel and so on, and the spreadsheet data, you can save it as CSV and of course store CSV files in HDFS. XML and JSON, these are the trees that I told you about. So I will also show you XML and JSON. They are very important to know. If you query data sets, these are also formats that are widespread. These I'm not getting into because this is for graphs, and this is for cubes, right? So this we will not cover. But basically these four we will cover. And then I'll show you binary formats later on when we do data models that are even more efficient than these. You must know CSV, XML, and JSON. Okay. So CSV, it means comma separated values. I'm pretty sure you've all heard of that, CSV. It's all, you can download files on the internet as CSV and so on. If you've worked with spreadsheet software, you probably saw that this is a way you can store your data. What does it look like? Well, it's comma separated values. So as you can see, we use commas to separate the cells of the table. But if you look these two, you will immediately understand how CSV works, right? So the first row is typically the header with the names of the columns. And then each row corresponds, each line of the text file corresponds to one row of the table, and each comma separates the columns. So this is CSV. There's a few things to consider because you might have commas in the values themselves. For example, what if you have a comma here? Well, it's okay, you just add quotes here, and then that means this comma is actually a real comma in the table and not a separation comma. But then you might ask, okay, what if I have a quote then in my cell, right? I'm becoming annoying, right? Well, in that case, you can just double it. So you have here the opening quote, and here you have a double quote. That means that it's an escaped quote. That is a real quote there. Then again, a double quote right there. That means that it's a real quote in there, right? So it's really straightforward to understand. But basically, what is amazing in there is that this is an actual table, something you can open in a spreadsheet software. It's actual data, but this is text. This is something as a human being. If I give you that, then I'm pretty sure you can build the table as a human being. It is human readable. This is what we are interested in today. This is a human readable table text format, because this can be parsed to a table. What's important to understand here is this is the physical storage as text of the data. This is the logical view of the data, right? And if you open it in a spreadsheet software, this is what you will see. If you save it back to CSV, this is what you will get, right? Okay. Now I have to warn you, the problem with CSV is that it's an enormous mess. I don't know how to express it otherwise. because people don't use the same conventions. Some people use commas, some people use semicolons, some people use tabs, some people use, people do not escape quotes in the same way. There is normally a standard that people are supposed to follow, but this is real life and people don't all follow the standard. So this is the reason why, in fact, when you open that in a spreadsheet software, you actually have to tell the spreadsheet software, are you using commas, are you using semicolons, and so on and so on, right? It's just life and we have to deal with that. But fortunately, it's not the same with XML and JSON. These are really standards. All right, good. Now, quick reminder, first normal form. The first normal form, I told you in the introduction, means that we have a table with no nested tables. We don't have tables in the tables, right? If this is the case, then we can save it as CSV. But this, when we have tables in tables, when it's not in first normal form, we cannot store it as CSV. It's obvious, right? How can you store, comma separated values in comma separated values, right? Basically breaks the whole thing in there. This is really not designed for nested tables. So that's the first normal form, but I warned you in the first week of the lecture, we are going to break these rules. So actually, we are going to actually deal with data like that, just not with CSV. Then something else that we will do is drop what is called the Boyce code normal form, meaning that instead of plenty of small tables in big data, what we love to do is join these tables in a bigger table. And this is what we actually store in a GFS. It's a pre-joins table. Why? Because it's a lot of resources to compute. So we pre-compute it in advance, and then we dump that on HDFS, the already joined table. It means we are not going to be in the Boyce code normal form, but we don't care. We are crazy in this lecture, right? We don't even respect the normal forms, and that's okay. And that's absolutely okay. Okay, so this is where the normal forms are going to go. And this is actually how we get trees, because I mentioned the trees. So this is called normalization. If we write a lot to the database, then everything we see in information systems for engineers applies. We write a lot of data, we highly normalize the data, we want the first normal form, Boyce code, and so on, because we want to avoid issues with the updates when you write a lot of data. But in big data, we are here. We are going to read a lot of data. So we dump the data to HDFS of S3 and we don't touch it anymore. We just read it. So it's read intensive. And as I said, we denormalize the data. So basically throwing that away is called denormalization. It's just that denormalization is a fancier way of saying that we drop the normal form. So if you want to sound fancy in front of your friends, you can just brag that we are denormalizing data in the Big Data for Engineers lecture, right? And the goal is to avoid the joins at all costs. Right? So when we denormalize the data, we throw things away. Instead of storing 3 tables, we just merge them together in a single table, which is awful according to information systems for engineers, but that's okay in big data. And then we can store that. In that case, that would actually work as a CSV file, right? It's a collection of tuples. Now, let's think a little bit. This collection of tuples, I'm not, of course, going to teach information systems for engineers here, but I'm just going to say it's a collection of tuples. Every tuple is a row in there, right? So let's look at one row. One row could be, for example, that the product phone, the price 800, customer John, quantity 1. It's this one. I basically picked that one. You see? So I picked these 4 values right there, corresponding to these attributes right there, and I just represented this as a mapping from the attribute to the value, 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 and this is what I get. But now that we are in big data for engineers and that we are going to look at actual syntax, this is how we are going to store it. See, it's exactly the same thing, except that this was a fancy presentation slide format. This is actual syntax. This is called JSON. So that's another way to represent the data. We could have used CSV, of course, in that case, as I showed you earlier, but we can also use JSON, and JSON is, this is what it looks like, right? So I have my attributes right there, then a colon, and then I have the values right there, and there's these curly braces that enclose that, right? This is one tuple can be represented as what we call a JSON object. Right? I'll get into the details of JSON. All right. What it means is that instead of CSV, we can also store that table with one such JSON object on each line. So this is the first row. The second row, Peter 2, you see, Peter 2. The third row, the fourth row, the fifth row, I didn't put them all because there's actually 6. I don't have the 6th one there because I didn't have enough room. But now you understand. So what do you see here? There is one record per line. And that was the same thing with CSV actually. But what was the difference with CSV is that in CSV, we had an extra line with the headers. You see, the headers were on the first line, but they were not repeated on every line. But with JSON, you notice that we don't have that header line. Instead, we keep repeating the headers on every line. This is the main difference between JSON and CSV. And we will see that it has to do with data denormalization later in the lecture. Right. So of course, it takes more space than CSV, but this is in big data how we like to do things. Right. So far, so good. So this is an alternate way of storing that table, but this time as a JSON format and not as a CSV format. Do we have a question?
Yes. So why do we use the term tuples and not dictionaries since we have key values?
Oh, it's the same thing as block, chunk, shard, split, and so on and so on. You can say dictionary, you can say an object, you can say an associative array if you want to sound fancy, you can say a record, you can say a tuple. There are plenty of ways to call that. And the way you call it really depends on the context in which you are speaking. So if you are in JSON, you're just going to say objects. If you are talking about a relational database, maybe you will see records, maybe you will say tuple. Tuple, probably people are going to say tuple if they are actually talking about the theory of relational databases because it's mathematical tuples. That's the reason. But all these words, record, tuple, object, dictionary, associative array, it's all the same thing. It's really all the same thing. It's just a key value map, right? Very good question. Thank you for asking. It's an opportunity to make it clear to everybody. Do not be scared when plenty of words mean the same thing. It's just how things are, right? This is because it's a community with a lot of people. They all have their mindset. They all have their vocabulary. It's the same thing when you talk with mathematicians, with physicists, electrical engineers. People might call things in a different way, and that's okay. Right? Of course, it's challenging to communicate, but if you do interdisciplinary work, then you just get used to adapting to other terminology. All right, so every tuple or record corresponds here to a JSON object. And I have one on every line, and I store that. Now, why is that useful? Well, it's actually useful when I start breaking the rules, because here I'm doing something really, really bad if we were in information systems or engineers, because I have tables in tables. But in that course, it's fine. But the cool things is that I can actually store that in JSON. I could not do that in CSV. In CSV, there's no way I can store that. It only works if I'm in the first normal form. But in JSON, that's okay. And how does that work is in JSON with that trick. Orders here, the second columns, uses these fancy square brackets right there, and I nest here an object and an object and an object. And I have just comma separated right there. So you see now how I have a table as an array of objects inside a record, that record right there. Right. It's like the Inception movie, you know, a movie in a movie in a movie in a movie. Now I can store tables in tables in tables and tables. And with the JSON syntax, I can actually do that. This is data denormalization. We have denormalized data. Denormalized data cannot be stored in CSV. We need another syntax, and this is JSON. There is one important piece, because that might actually sometimes bring confusion. It did not escape you, probably, that this nested table right there inside has these square brackets and the comma separation, but here, this outer table didn't. I didn't put any square brackets in there. I also didn't put any commas in there, right? So you might be wondering, why didn't I do that here? But why did I do that in the nested table? This is also a pragmatic thing to do. And the reason is these tables right there are usually going to be smaller, but these outer tables are going to be gigantic. And with gigantic tables with billions of records, it's just so much easier to handle if you just store one per line, but without the square bracket and the comma, just one object per line, and that's it. Right. But the nested tables will be arrays of objects. All right. So again, I keep throwing the term denormalization because again, that's something you can use in order to sound smart in front of your friends. So we are denormalizing data in this lecture. And that means that instead of having tables like these that are homogeneous, because it's always the same types in the columns, and flat, because we don't have nested tables, in big data for engineers, we have heterogeneous collections of arborescent items. Heterogeneous because I can have missing or extra fields, or it can be a mess. Arborescent is just a fancy term for tree-like, because these are actually the trees that I told you about. If you don't see the trees yet, don't worry, you'll see them in 2 weeks, because I have an entire lecture on how we actually build the trees out of that. All right? So this is how we go from relational databases to what can be called document stores. Any questions so far? Everybody's following? All right, so the one word for today to remember is denormalization. We denormalize data and we go away from just CSV and embrace the JSON format in order to store data when there are tables in tables in tables in tables in tables. All right. So there is actually a name for that. So CSV and tables, that's called highly structured data. It's highly structured. This is the data as we know it since the 1970s, right? Nicely arranged in a table and so on. This data that is denormalized, JSON, XML, and so on, it's actually called, surprise, surprise, semi-structured. It's neither as structured as tables in normal form, but it was also not quite unstructured as if you would throw a novel in your data lake. It is somewhere in between, right? So we denormalize tables and we get trees. This is actually an example of tree when I drew it. This is called semi-structured. Semi-structured data is the same as tree-like data, is the same as denormalized data. All right? And now, this is what I'm going to now tell you about in terms of the data sets that are like that are denormalized and that we can store in JSON, and as we will see in XML. All right. JSON and XML, these are two standards. XML comes from the W3C, it means the World Wide Web Consortium. It is the same, it is a consortium that was co-founded by Sir Tim Berners-Lee, who invented the web a bit more than 30 years ago. And this is a consortium that has people from many companies, Google, Microsoft, Apple, IBM, Oracle, basically people gather and they come up with standards. So there is the HTML standard, there is HTTP standard, REST APIs, actually that standard, there is XML, and plenty of other standards. Right now, for example, one of the standards they're working on is how to have a better thing than passwords over the web, a better authentication mechanism to connect to websites. So this is the W3C, that's the World Wide Web Consortium. Another standard body is ECMA International. They are the ones who do JavaScript, for example. This is where JSON is now standardized. It's an ECMA standard. So there is XML by the W3C and JSON by ECMA International. All right? Standard is very important because if you have a standard, it means everybody in the world agrees on what XML is and JSON is. And as I told you, XML and JSON are a bit better followed than CSV as standard. So if you open XML or JSON, it's more likely that it will be clean. CSV might bring you a few challenges to open. And I'm sure that when you first query CSV data sets, you will see the sort of challenges that you have with CSV because of these different ways of using CSV. All right. So any questions so far, or are we good? All right, I'm assuming you're following, right? You're silent because you're following. Maybe you're eager to actually see JSON in action. All right, what is syntax? So syntax is basically text. It is when you have data that you store as text. What that means is you store files on HDFS or on S3, but you can open them in a text editor and actually read them as a human being. The golden rule, when you store CSV or JSON or XML, is that it's called a language. Just like English or German or Java or C++ and so on, language in computer science is actually a word that basically means a set of a load contents. Whenever you open a file on HDFS, there is a question you can ask: is that JSON? Is that CSV? Is that XML? Or maybe expressed differently, is that correct JSON, correct XML, correct CSV? Or are there mistakes in there? In other words, can you open it? For example, you can try it with, I don't know, a spreadsheet file. If it's corrupt, you will just get an error message. But if it's not corrupted, then you can open it and it will actually display. Well, the same thing goes with the data set. So you can ask the question, is my file a well-formed, that's the term, a well-formed JSON file? There are two possibilities. Either yes, it is well-formed JSON, and then you can go ahead and query it. Or it is not well-formed JSON, but then you have a problem. You cannot open it, right? Maybe you need to fix it or whatever. You can ask the same about CSV. Is it well-formed CSV? Of course, given all the local dialects of CSV, right, that people use differently, or is it not CSV? If it's not CSV and you try to open it in Excel, you're going to get an error message. Or maybe you're going to get a lot of mess in your spreadsheet. And XML is the same. Either it's well-formed XML, and then you can go ahead and query it, or it is not well-formed XML, and then you have a problem. You need to fix it. So this is a yes-no question, and that is called well-formedness. Remember that term, well-formedness. So if you see a document, you can ask yourself, is that well-formed JSON? Is that well-formed XML? Is that well-formed CSV? All right. Okay, here's an example of XML. XML looks just like that. I will, of course, go into detail about what it is, but the first thing you see about XML and how you recognize is the angle brackets, like this. Right. This is JSON. Okay, that's familiar because I've already shown you some JSON, right? So by now, you basically know how that works, right? You have these curly braces with this key value model, with all these key values that are the dictionaries, if you want to call them dictionaries. This is also a dictionary. And you have also arrays. That's also something you've seen with the square brackets right there. Right? So this is JSON. All right. Let's now dive into the two. I'll first dive into JSON. I'll show you all the aspects of JSON, and then we'll dive into XML, and I'll show you all the aspects of XML. It is a must. As a data scientist, you must know these syntaxes. Why? Because they are used everywhere. So you need to actually understand them and make sure that you can deal with them and parse them in your brain, and yet that you can fix them if there's any problem. All right, so let's start with JSON. Why am I starting with JSON? Because that's the easy one. So JSON has the reputation of being much easier than XML. All right. Okay, so let's start then. So I'm just going to give you the building blocks. In JSON, there are 6 building blocks, 6 possible kinds of JSON values. So I'm just going to go through each one of the 6. The first one is strings. A string is the same thing you see also in Python, in Java, and so on. It's whenever you have these quotes right there. Right? You also see them in Excel, actually, or in CSV if you want to make sure the comma is recognized differently. So this is just text that is just a character string, just a word or text or whatever. So double quotes. It has to be double quotes. Right? What is going on here? This is when you have characters that are a bit unusual. This is what's called escaping. For example, you might have a new line character in your string. You might have a tabulation, or you might have some emoji that you want to put in there, right? So in that case, you need to use backslashes. It's not going to surprise you if you already know how to write some C++ or Java, because backslashes are also common in many programming languages. So maybe this is not new to you. For example, you might know that \n actually is a new line. N is for new line. So \n means that it's actually foo and then bar on the next line. But of course, you cannot do it in JSON. So you need to put \n instead. Okay. Then bar. And this is another way to escape. This is \u for Unicode. And this is here just some code. It's the code of the emoji that you want to put it. Where I'm saying emoji, it could be also something else than an emoji. Maybe it's a special character of some alphabet, or maybe an umlaut character in German that you want to make sure is displayed properly. So Unicode is just a very big character catalog with all these characters and emojis and then you just look up the character that you want and just put \u and the four characters that are basically the code of what you want. And what's going to happen is that when you then open the file, I don't know if you open it with some advanced JSON editor or whatever, then you might actually see the actual emoji or the actual character appear instead of \u and the escape sequence. So basically, by having these escape characters, you can make sure that you only use the very basic characters of English. All right, so these are strings. Then we have numbers. This is probably going to be the easy one. This is 3.1415. Dot, not comma. Some languages like French, it's a comma, but here it's really a dot in JSON, period, decimal period. So you can have decimal numbers. You also have the scientific notation that you might be familiar with calculators. So this is basically -1.2345 times 10 to the power of 5. It means that there are 5 zeros in there. So you basically need to move the comma 1, 2, 3, 4, 5. So this is actually 123,450, this number, right? So this is the power of 10, all right? This is called the scientific notation. So in JSON, you can have numbers. Of course, you don't need the comma. If you want just an integer, that works too. But basically, you can have numbers in JSON. No quotes, that's the difference. Here, there are quotes for strings, but not for numbers. There are no quotes around them. Okay, strings, numbers, Booleans, easy, true, false, no quotes. That's just the yes, no, basically. It can be true, it can be false, all right? Well, I don't have much to say apart from that. There's true and there's false. And finally, there is null. Null is a special value that basically means it's not there or you don't know, right? So you just can put null. It exists also in many languages like Java, C++, and so on and so on. You also have this null that is just the absence of the. All right. Check the time. Oh, we still have a few minutes. All right. So next, so these four, string, number, Boolean, null, these are the atomic ones.
So Gislan, there's a question. So is there also undefined?
No, there is just null. Null means undefined, absent, and so on, and yeah, everything. We will see though that you could also completely remove the key. That's another way. So either you say key colon null or not at all. It can also just be dropped and it's not even appearing. Maybe this is what you mean with undefined. I'm not sure. Oh, in JavaScript, yeah, okay. So no, in JSON, there is really just null in the syntax. Yeah, I don't know how, if you use JavaScript, what undefined would be mapped to. I'm not sure. Maybe it would be mapped to not at all. I don't know. That's a good question to investigate. But in JSON, there's really just that. That's all. There's nothing else. All right. And now arrays and objects are the last two. It's really easy. An array uses these square brackets. Here I'm opening and here I'm closing, and then comma separated. Now, the beautiful aspect of that is that it's called recursive in mathematics. It means that what you have in the array is absolutely anything. Strings, numbers, Booleans, nulls, arrays, objects, anything you want, you can put in an array. Right. It's really the Inception movie, table in a table in a table. You can have an object in an array, in an array, in an object, in an array, and so on and so on. Right. All right. So an array is just a comma-separated list of any values enclosed with square brackets. Objects, they don't have the square brackets, they have the curly brackets right there. And here we are back to the key value model, right? So we have the keys right here, and we have the values right there. The keys must be strings, quoted, double quoted. And the values, just like in arrays, can be anything. Can be an array, can be an object, can be a Boolean, can be a number, can be a null, anything you want. This can also be called a dictionary, a record, a tuple, an associative array, a map, anything you want. This can also be called a list in Python, a sequence, a tuple maybe also. So this is actually a bit blurry. Some languages would call that a tuple, maybe in Python, but again, this really depends on your perspective right there.
So we have another question. I assume like in dictionaries, their keys are unique, right?
Yeah, I'm going to come back to that. The short answer is yes, all keys are unique in the sense as for the lecture, all keys are unique. If you look to the standard, it's actually not a requirement, it's only a recommendation. So if you read the standard, it says the keys should be unique, but they do not say the key must be unique. That's the subtlety. But you probably know computer scientists, whenever they see a should, they treat it as a must, because you're going to get into problems if you have duplicate keys. So the short answer to your question is no duplicate keys, exactly like a dictionary in Python. All right? All right. Okay, and I'm coming to that basically. So now examples of mistakes in JSON. This is not okay. This is not okay because keys must be quoted strings. This is also not okay. A key cannot be an integer. It must be a quoted string. This is not okay, and now it answers your question. You cannot have duplicate keys in here. It must be unique. But I put the should right there because that's what I'm telling you, that it's a should, and there are a few people in the world that actually might use duplicate keys, but the vast majority of JSON implementations actually do not allow for duplicate keys. So if you don't want to run into troubles, do not use duplicate keys in JSON, and then you're going to be fine, right? All right. Because then you have the problem that it's no longer an associative array, right? It's no longer a dictionary if you have duplicates. Okay. And then if you use JSON to store data, this is what it can look like. This is a data set we're going to use called the Great Language Game data set. It was a game where people had to guess the language based on some audio recording. It's been discontinued now, but the data set is still there. These are the 4 choices that people are given. This is the file that is playing the audio. This is the guess that the player entered. This is the correct solution. So in that case, they were wrong. It was an Italian recording, but they said German. This was the date at which that was asked. And the country, I think it's probably the country of the player who was playing. And we have, I think, 16 million of these, 1 per line. So you will query actually that data set, but this is just an example of JSON basically, that can be used in a data set. All right. So as I told you, now you know JSON because I showed it to you. So now you look at it with a fresh perspective. You know when there is a table, you know how to represent it as JSON, but in that case, there is no nested array there, right? Because this is in first normal form. But if there is a nested array, then you have the array of objects, right? Okay. I think I'm going to stop here because XML is slightly more complicated, so I'm going to do that next week. But now you know JSON. There's everything. Actually, you already know pretty much everything about JSON, right? All right, and then you can go ahead and download, if you want to look up a few JSON data sets over the internet, download them, open them, and look inside, and you will see, you will understand what's in there because you know strings, integers, booleans, null, objects, and arrays. Okay. So I repeat the keyword of today, it is denormalized. We are looking at denormalized data because we are throwing away the normal forms. We allow nested data, we allow heterogeneous data. All right. Let me just ask the final question to make sure that you followed what I told you today, and then you will be good to go. All right, we are on the positive sides today. So everything was understandable. Perfect. So don't hesitate to look for JSON, to read the JSON standard because it's actually not so long, and to download JSON datasets and look what is inside. And again, this goes to HDFS. When you have JSON datasets, you can put them on S3, on HDFS, on Azure Blob Storage, and then later we'll query them with MapReduce and Spark. Thank you very much. Thank you, Wenji, for moderating. I think that I see people are already leaving, probably hungry. So enjoy your meal and enjoy the exercise sessions, and see you next week. Thank you.